back to my channel, and today we will be studying theory of evolution. Okay, this is not the exact genetic algorithm, which is a lot more tougher. We will see a much scaled down version, easier version of the genetic algorithms. First, I will tell you what the problem is. Genetic algorithm deals with inside our DNA. A lot of coding or properties are encoded inside the DNA. Okay, like how the amoeba, over time, the coding in the cell, it changes, it evolves, and after a long time it turns into a more complex animal, right? So this study is called genetic algorithms. Okay, genetic algorithms. But we will see a very scaled down version to code on Python of how this genetic algorithm works. But it is not the original one. It is a much simplified version for total beginners. Okay. So you have a series of ones and zeros, a string made up of ones and zeros, which every bit, every one or zero is representing a character in the DNA. Okay, it encodes as character in the DNA. Suppose this can be a sequence of ones and zeros. So after a certain probability p, okay, small probability, p is a small probability. When p will take a certain value, what will happen, at any random index of this sequence representing the coding inside the DNA, say at the 10th position, at the 10th index, at index, maybe how many terms are there, bits are there, 1 2 3 4 5 6 7 8 9 10 11, okay, 12 13 14, 14 bits are there. Suppose at index 9, the ninth bit, okay, randomly we will select an index, ninth bit, and we will check the value at that bit. 0 1 2 3 4 5 6 7 8 9. This is the ninth bit. This bit is 1. Okay, so what we will do, this bit is 1, so we will make this bit 0. Okay, uh, this bit will become 0. If it was a 0, we will turn this bit as 1. So after a very long time, what will happen with a small probability p, always after a small probability p, at a random index of the DNA coded information, we will toggle the value of the bit. And after how many time, after how many years, or after how much time does all the bits in this DNA coding becomes 1, or it becomes evolved? That depends on how many, what is the probability with which evolution is happening, as well as the length of the string, right? So this is a scaled down version problem that we will be seeing how to code, and we will be using the random library of Python. Okay, I'm using Jupyter notebook. So first I will tell you about file handling. Okay, so we will zoom it a little bit. Okay, yeah. So first I imported random. Okay, then we have to write with open. The open takes two arguments. Okay, first is the name of your file. Suppose this gene.txt, this file does not exist. Okay, then it will create gene.txt for you, and you have to tell in which mode do you want to open this file. Do you want to open this in read, write, or append, or there are modes we will look further in the video. First we are opening in the write mode. That means I want to write something inside this gene.txt file. Okay, let us first see. I will go back and show you what is there in this gene.txt file. Okay, This is the data inside gene.txt file. Okay, this is gene.txt, and this is the data series of ones and zeros, that is representing the coding information inside the DNA. Okay, now what we will do is we will go back to the code. Okay, I will not execute this. Okay, this one. So what we are doing, we are opening this gene.txt file in write mode as file. Now this gene.txt inside the code, it will be represented as file variable. Okay. Now what we were doing is I created that data, that encoding data series of ones and zeros using this code. Okay. This is not important for us to understand. Okay, that was for generating the data. Okay, now we can read the file I am creating with opengene.txt. This is the name of the file that you have to open, and no arguments means you want to read. When you are in read mode, you cannot write anything to this file. Okay, you can only read. This is read only mode. Okay, and it will be identified using my file variable. Now you can print the data of the file using the file name variable my file dot read function. Okay, and we are printing what is there, right? So let us execute it once to see. Yeah, we will run this. See, this is the same output we got. This is the original text file. Okay, now there are different modes for file handling. That is the second argument of open function. Okay, there is one only read. Either you can write nothing or you can write R in double quotes. One is write new information and erase everything before. So the above one that we used, file name dot write, this was opened in the write mode, right? Yes, and when you use this mode, whatever existing was written in the file, everything will be deleted and new things will be written inside the file. Then another mode is A, append mode. That means the existing data in the file will remain. In addition to it, at the end, new data will be added. That is known as appending, or adding at the end of whatever was there in the text file. Another mode is R plus mode. That means you want to read as well as write inside the file. Okay. Now we will look at some random functions that will be used in coding the theory of evolution code. Okay. So first I'm importing the random library. There is a function called random.randint, and you have to give a start value is the first index and the end value is the second index. So this function when executed, it will produce random integers from 1 and 5, and 5 is included. Means 1, it can give you a random integer. Okay, well, let's change the color. It can give you a random integer 1, 2, 3, 4, 5, and 5 is also included. Whenever you execute, it will give one out of these 5 answers. Okay. Okay, so next is random dot rand range. Okay, this is different from rand int. It will also give you integer values only randomly, but it will exclude the upper limit. That means if you give rand range 1 to 5, it will give you random numbers between 1, 2, 3 and 4 only. It will exclude 5. The upper limit it will exclude. Okay. Next is random dot random. Random dot random function, it will give you decimal numbers from between 0 to 1. Okay, not integers, decimal numbers. Next is your random dot rand range. Okay, this has 3 arguments. Okay, you can give a starting value, you can give an ending value, And you can give a step size. That means if you start from 1 and every random number will be in this series. 1, from 1 you add 2, 3, 3 plus 2, 5, 7, 11, so on till the last odd number 99. Till here it will give you any one value randomly. That means it will produce odd random numbers. To generate even random numbers, what you have to do is, you if you change the starting index, if you change the starting as 2 and you give the ending as 100 and you give step size as 2, so this is the argument, sorry, not yes, it should be round brackets because it's an argument to the function, right? If you give this as argument to this function, what will happen? It will give you the random numbers, one of these numbers, 2, then 2 will be added to 2, 4, 6, 8, 10, 12, so on till 100. Any one even number, okay, randomly. Okay, that is the difference. If you give the step size, it will generate the series by adding from the starting number the value of step size, and out of those numbers it will select and give you one of the number randomly. Okay, and then is a random dot choice function and its argument is a list. So what will happen, it will randomly give you one of the elements of the list, okay, as output. Let us run this and see what we get as output. Okay, yeah, we will just run this cell. See, first was rand int, it is giving between 1 and 5 integer. Rand range 1 to 4, it will give you a random number. Random dot random, a decimal number. Rand range, it will give you an odd number, right? 65 is odd number. And random dot choice, one of these elements it will give you. We will run 2 more times and see. See, it is again giving odd number only. And our rand int gave you a 5, the upper limit also, right? Again we will run it. Yeah, we'll run this cell again. Yes, again 63, an odd number. Okay, and if I start it with 2, it will give you even numbers. Let us see, right? 60, 52, 88, right? Yes. Now we will see another another important function in random library, random dot sample. Okay, in this there are two arguments. First argument tells you the list from which you want to randomly select any three or any any number of values you want to select randomly, any random subset. Okay, then you use random dot sample. Okay, suppose I don't want just one random value from this list, I want three random values from this list. So it will give you a sample of size 3 or a subset of size 3 where elements are selected randomly. Let's run this. Every time you will get a different, see, date, cherry, apple. Again 2 more times we will execute this. Okay, yes, date, elder, other earlier it was cherry, now it is elderberry. Okay, again we will see, right now it is elderberry, date, banana. So this subset is different than the previous every time. Okay, now we will come to the code of theory of evolution. Okay, first we will see this part, what we have written, and then we will go to the evolve function. Okay, so first what we are doing is, with open, we are opening the file gene.txt as my file. Then we are reading the content of our file in a variable called x. Then we will convert the data. If you use the list function, then this variable's data, the data was a series of ones and zero, this would be converted into list. Okay, and this list would look like this, an array of all the bit values, right? All the bit values, one bit at a time, will be stored in this list X. Okay, we printed this value of list X. Okay, and then before this dotted line, the value which we have printed is unprocessed data, right? It is the original data that was present in my file. Okay, DNF file, gene file. Now what we are doing is, we will iterate, we are writing a loop, how many times we will we will run this evolve function. Okay, uh, yeah, this evolve function takes an input the entire array, the list of X, है ना? And we are running the evolve function 10,000 times. Okay, to see how much time it takes for the entire list to become all ones. Okay, so what we do is, we will randomly select an index. Okay, where we will see, we will toggle the values. Okay, so we want an integer value, because that would be an index of our list. So we are using random dot rand int, and rand int, it includes both the endpoints, right? So we are giving our list's index is starting from 0, and the last index is the length of the list minus 1, right? That is the last index, one of the index value we are choosing randomly, and p is the probability. Okay, so randomly we are choosing an integer from 1 to 100. Okay, and if the value of p is 1, then only we will toggle, then only the gene would evolve, otherwise it would not will evolve. So what is very small, what is the probability? P is nothing but 1 upon 100, right? So only 1% of the times the gene would evolve, and rest 99% of the times it would not evolve. That is its coding value will not change. 99% it will not change, only 1% chance is there that value of p variable would be 1 and it would evolve. Okay, the characteristic inside the coding would evolve. Okay, so if p is 1, whenever p is 1, then what we are doing, at this random index of the coding value, if the value is 0, then what we are doing, at that index we will change the value of the encoding to 1. That means our gene has evolved, right? And to, because in the output it will be very hard to notice that whether our gene has evolved or not. So what we are doing, we are converting this integer index into a string and appending to tell you that this position, the coding has changed. Otherwise in the output it would be very hard to note what changes has happened. Okay, and similarly, otherwise if at that random index the value is 1, then we are changing that value to 0. Okay, okay, now let us see, execute this code and see. We will execute and see this code. Okay, so before this dotted lines, that represents the unevolved gene value, right? And after this dotted line, it represents at what positions the value of p is 1 and some toggling has happened, right? Originally if it has become 0, that means originally there was a 1, right? If it has become a 0, it was originally 1. It has become a 0, originally at this position it was 1. And wherever there is a 1, right, after wherever there is a 1, let us see, somewhere 1 is there. Okay, we have to run it more times, then only it would. Let us run this code more times, okay? Maybe one more zero I will add. Then it will evolve with a one. Okay, let's see. So it will take plenty amount of repetitions to get after evolution all once, right? It will take a lot of time, right? Let us see if there is any one C, right? One C. So this, no, it has not changed to one. Okay. It will happen after very many repetitions, right? Because it is happening randomly. So hope you like this video. Please share it with your friends, subscribe to my channel, and stay tuned for more Python programming videos. Bye bye.